space nerds, and welcome to MicroCosmos. Today we're going to talk about spacecraft navigation. Have you ever wondered how a spacecraft knows where it is in space? It relies on a suite of sensors called the Attitude Determination and Control System, or ADCS, and its talented mission planners on Earth. ADCS usually consists of two types of optical instruments, the star trackers and the sun sensor. Sun sensors come in different types. There are presence sensors that will provide a 1 or a 0 if the sun is in or out of the instrument's field of view. Digital and analog sun sensors are more complex and can indicate the angle of the sunlight received. A thin slit atop a chamber allows a line of light to fall on photodetector cells. These cells give a voltage when the light is on them, which is registered electronically. By orienting two sensors perpendicular to each other, the direction of the sun can be fully determined. For instance, the Dawn spacecraft has 4 sun sensors, one on each corner of its cubic structure, that would allow quick determination of its orientation. Star trackers are much more complex, but the basic principle is kind of the same. They measure the position of stars using photocells or a camera. They require high sensitivity in order to see stars, and may become confused by sunlight reflected from the spacecraft or engine exhaust plumes. They take photographs or voltage data from the stars emitting light in the sensors, pick out pre-programmed navigational stars, and use that data to determine how the spacecraft is oriented in space. Commonly, there are 57 bright navigational stars in use. However, for more complex missions, entire star field databases are used. The star trackers will identify constellations in some of these stars, filter out problematic ones that may be due to instrumentation error or apparent magnitude variability, and analyze the remaining field of view. The database for these stars can either be stored onboard the spacecraft's memory, usually in a separate electronics box dedicated to the star trackers, or processed by mission control engineers at the ground stations once the data has been downlinked. Other methods of attitude determination are magnetometers that measure the presence and strength of a magnetic field, and when used in a 3-axis orientation can determine the direction. These are commonly used in smaller satellites like CubeSats, which lock onto the Earth's magnetic field. Inertial measurement units and accelerometers can be used as well, which can detect the pull of gravity on the spacecraft, which in turn can help determine the orbital attitude and orientation as it orbits a planet or moon. These instruments are all great, but they will only tell you where the spacecraft is facing and if it's near a magnetic field or gravitational object. To determine if it's in an orbit, its velocity or other important data, mission control is needed. The easiest and most tried and true method of determining those aspects of a spacecraft's flight comes from communicating with it. When the spacecraft talks to Earth, it transmits radio waves to the deep space network. As the spacecraft is moving and it emits radio waves, each wave will be closer or farther away from the previous, if the spacecraft is moving toward or away from the observer, the DSN, respectively. It's like hearing a siren from a police car. As you approach the siren, it sounds higher pitched, but as you move away from the siren, it will sound lower in pitch. By analyzing the frequency of the radio signals from a spacecraft, it's possible to determine its velocity. By using several ground stations and listening to the same spacecraft, it's possible to determine which direction it's traveling in and how fast it is traveling. Spacecraft navigators are kind of the unsung heroes of a mission team. Without accurate predictions of where a spacecraft is and where it's looking, those spectacular pictures and groundbreaking discoveries might have never taken place. I hope you liked this week's episode of MicroCosmos. Be sure to like and subscribe and turn on notifications to catch future episodes. Have a good week.